Hi everyone, in this lesson we're going to learn some of the basic definitions for circles and all about circles. So these are the notes that are yellow and orange. They look like this. In class you're going to cut out the circle, unless you've already done it, and it's going to end up folding like this. Okay, and then we'll glue on the back part of that. And then the other part will be a pocket for your examples. So let's look at all of our definitions. So I'm going to start back here. So the basic definition of a circle. So a circle is the set of all points that are equidistant from a given point, which is the center. So the whole side is the length of that distance, which is your radius. So a semicircle is half of a circle. And concentric circles are circles that are on the same plane that have the same center. So that would be like a bullseye, because they all have the same center. That would be concentric circles. Okay, awesome. Let's look at some of the vocab in the inside. So we'll start with radius over here. So a radius is a segment that has one endpoint on the circle, or at the center. So one endpoint at the center and the other on the circle. So we're going to do some highlighting and highlight each of these pieces. So you're going to need a couple different colors. If you don't have any highlighters with you, you can do that part in class. So our radius would be just to the center. So diameter is a segment that contains the center and has both endpoints on the circle. So that would be all the way through. All of that. So those definitions I think we are pretty good with, because we talked about those when we were doing area and circumference of circles back in chapter 7. Okay, so the next one we're going to look at is a central angle. So that's an angle whose center, or whose vertex, sorry I got it backwards, whose vertex is at the center of the circle. Okay, so this angle that's right here, that is a central angle. Any of those angles that have the vertex at the center, so like this angle here, that would be a central angle. I'm just going to draw the angle mark so you can see what I'm talking about, but it would be an angle with those sides. So any angle formed with two radii. Okay, so we're going to switch down here to arc. So an arc is part of the circle. And back in chapter 7, we talked about how to find the arc length using that angle over 360 times 2 pi r. Here we're going to find arc measure, which is like we're measuring it in degrees instead of length, like with a ruler like we did before. So it says that the measure of, well, let's talk about minor arc, and then we'll get to that because you need to know this. So an arc that is less, or a major arc is an arc greater than a semicircle, and a minor arc is an arc less than a semicircle. And if we have two adjacent arcs, that means they have arcs of the same circle that have exactly one point in common. Just like adjacent angles have one side in common. So like this arc here, and then this arc here would be adjacent because they share that point right there. Okay, so now on to arc measure. So this isn't the same as arc length, like I was saying. This is the measure of the arc in degrees instead of measuring in like centimeters or inches or feet or anything. So the measure of a minor arc is equal to the measure of its central angle. So this arc that goes from here all the way down to the bottom to the green one would be equal to 90, since this is a right angle, 90 degrees. So the measure of a major arc is the measure of the related minor arc subtracted from 360, because all the way around the circle is 360. So if we wanted to measure from here, the pink line, all the way around to the blue line on the other side, it would be 360 minus 90, because this part's 90. And then last, the measure of a semicircle is 180 degrees because it's half the circle. So let's look at our yellow examples. So for the first column, we're going to name some pieces. So there's a lot of different answers that we can have for these. So we're just going to name a couple. So a minor arc, remember, is less than half. So this would be half. So a minor arc could be AC and CE, would be two minor arcs in this circle. AC and CE. What would be two other minor arcs? Good. I hope you said AD and DE. Just like with segments, it doesn't matter which letter you put first. So AC and CA are the same. To show that they're arcs, we put a curve over the top instead of a straight line. Okay, so semicircles, remember, is exactly half. So find a diameter and look for the semicircle. So that would be this piece. But we can't just say AE, arc AE, because I don't know if you mean this arc here or this arc down here. So for things like that, you'd have to use three letters. So arc ACE. ACE would be one semicircle. And then if we looked at the other diameter, we could have DEC. So those are our two semicircles we got. Well, we could do it the other way too. We did ACE, we could do ADE, it would be the bottom part. And then we did DEC, so we could do DAC for the top half. Okay, so a major arc that contains point A. So remember, a major arc is more than half, but we wanted to have point A in it. So let's start at point A and see what we got. So if we go down, we get to E, that's half, so we'd have to go to C. So arc A, EC or ADC. If it has four letters, you only need three, but we need A and C at the end, so you can pick one of the ones that are in the middle. So A, D, C, and this would be the same as AEC. They're the same. So let's find some more. So if we went around this way, we could have ACD or AED. Well, that's the same as AED. And then we can also start at another point. We could say DAE would be another one. Okay, we could write a couple more, but I'm going to stop with that for those. But remember, major arc is more than half. Okay, so let's find the measure of some of these angles or arcs in this next example. So remember that the arc is equal to the central angle and vice versa. So if this angle is 32, that means that arc BC is going to be 32. And if this arc is 58, that means that the angle is going to be 58. We still have a straight line here, so we have supplementary things so we can find the measure of those other ones if we need to. Okay, so they asked for arc BC, which we already just figured out to be 32 degrees. They asked for arc ABC, which is a semicircle because it intersects with the diameter. So we know that that's equal to half of it, 180. So now we want arc BCD. So that would be this whole arc, and we know the two pieces. So that would be 32 plus 58, which is equal to 90. And then arc AB, so that would be this piece. So remember we said that that whole thing was 180. So to find just this part, we would do 180 minus 32, which is 148. Okay, so let's try the bottom one. So same idea here, okay? So arc ADC would be this whole part. So that's a major arc. So remember we said it's the 360 minus the minor arc. So this minor arc here is 90. So this would be 360 minus 90. Arc AB corresponds to its central angle, so that's 50. Arc BC, well, we know these are right angles, so 90 minus 50 is 40, so that means that this arc is 40. And arc ABC, well, we got our right angle, so we know that that one's 90. Okay, so make sure you wrote down questions if you didn't understand where any of those numbers came from. So what I want you to do now is pause your video and try to do all of those on this side. Okay, remember about semicircles are 180 and that the whole circle equals 360. So go ahead and pause and come back and I'll go over the answers for these. Okay, so here we go. I know there was one this one right here, BC. If you look at BC, you don't know if it's BC down here or BC up there. So it should have had another letter in it. I picked this one to do BDC. So that's why I wrote it, and that one would have been 142. Okay, so go ahead and check your answers. You should like star ones that you didn't understand where those numbers came from, and we can talk about it in class tomorrow to make sure you understand all of that. And that is it for 10.1, circles and arcs. Warner out.